Hi, my name's Chad from Electrona, and I'm joined here with my colleague Kurt Roberts. We're going to be talking today about managing data in disconnected systems and using automation to sync information across those systems. Here at Electrona, we are a managed service provider, and as such, we have a number of different clients and a number of different systems, including multiple customer MDMs, multiple management tools, and multiple other communication channels and places that we store information about our customers and their devices. We are trying to figure out how we can ensure that the data in our customer systems, such as their employee directory, end up associated with the appropriate devices and computers that we're managing, as well as updating places like our CRM, our ticketing system, and other monitoring tools that we use with the information about the users that are using each of these devices. The problem that we're encountering is that humans are not particularly good at doing these things repeatedly and consistently. Although we have, good documentation and process procedures internally within the organization, we get this right about 80% of the time when we've got humans doing it. However, that 20% of misses can really cause problems when you're trying to solve a customer issue quickly and ensuring that you have the data in the places it needs to be. So the good news is computers are particularly good at solving this problem. And with that, I'm going to hand over to my colleague Kurt, who's going to talk a little bit about the system that we built to accomplish this problem.
Thanks, Chad. So when you're talking about synchronizing data between systems, you're going to really run into three big problems. The first one is we need to be notified that the system has changed the data. And so we have a system of record for that purpose. In our case here, that's MDOYVR. All of our updates are made in MDOYVR, and then they're synced to the other systems through the synchronization system. The second one's transforming that data so that all of the systems understand the data that's coming out of MDOYVR and are able to format it their own way. And the final one is being notified that this is happening and that everything's happening successfully and correctly. So while MDOYVR has some webhooks, we actually load data from it in batches every 5 minutes. The advantage of this model is it's a little less tightly coupled to Bamboo, which means if we need to add another HRIS system someday in the future, we have a little bit more flexibility. So the first thing we want to do is check that we're actually seeing a change. There are events that make changes within Bamboo that we don't need to deal with because it's not data we're touching. So to do that and to meet security requirements, we store the email, the last updated date, and a hash of the fields that we care about in a DynamoDB table. We want to do that to make sure that we're not storing any PII in the sync system and keeping it in appropriate locations in the systems that's managing it. So whenever a new event's raised, we hash it and compare it to the one on file. If nothing's different, we stop there. Here we're looking using that function so we can see if it does have changes. We'll record the changes with the new hash, and then we'll publish that message to the SNS topic that the other functions listen to. Each of the systems in this diagram are represented by a Lambda function in the actual code base. So that Lambda function will receive the Bamboo formatted record, and then it can marshal it to be in the correct format for that system. There's an example of the Lambda function for the Jamf device user updater. This particular function handles taking the devices that are assigned to someone as assets in Bamboo and assigning those users to those devices within Jamf. Here you can see how we do it. We'll take the data from Bamboo, we'll clean it, make sure that it's XML safe, and then we'll format a message. Finally, we grab the serial number out of Jamf by looking it up using a get. We'll then, on a delay of about 0 to 10 seconds, we'll put the record back to the Jamf API and update that record. We handle this in a loop in case someone has more than one computer. We're able to update all of them that are tracked in the asset management system. That brings us to the third problem, which is monitoring it. For real-time monitoring, we set up Slack notifications. This showed us that we really needed a way to handle and capture errors. So we took that a step further, and as represented by the red line at the bottom, we created a replay queue. So now we're saving errors into a replay queue where we can inspect them and retry them. The most common error we have is running afoul of rate limiting, particularly with HubSpot. So every 5 minutes, another Lambda function looks in that queue. It arbitrarily grabs 20 items if there are more than 20, or it grabs all of them if there are fewer, and then tries replaying them across the top bus just as though they were new events. Oftentimes that sorts everything out, and then we can periodically check the queue and remediate by hand any that are still there. So that's a high-level view of the sync system. Thanks for listening. You can visit us at electrona.com or on GitHub, and we're also in the Mac App and Slack channel.